Today we are going to be talking about linear systems of equations. We're going to start by talking about two-variable systems of equations. Now there's three things I need you to know about this. One is a system of equations is two or more equations with the same variables. I also need you to know that the solution to a system of equations with two variables is the ordered pair where you have an x and a y that satisfies both equations. So it's an x and a y value that makes both equations true. And then I also need you to know that linear systems can have one solution, they can have no solution, or they can have infinitely many solutions. And we're going to explore three different methods for solving systems of equations, and then through those methods I'll show you what it looks like to have one solution, no solution, or infinitely many solutions. So now let's look at some examples of how we can graphically solve a system of equations. And we're going to look at four different examples of graphing. So our first system that we're going to look at is going to be the equation 3x minus y equals -5, and the equation 4x plus y equals -2. We're going to solve this graphically. Now, the first thing we need to do is we need to solve each equation for y. So, in the first one, how I would solve this for y, I would first add y, so we can get 3x equals -5 plus y. And then I would add 5, so we can get y equals 3x plus 5. You can do what you want, but the whole goal is to get y by itself and make it positive. In the second equation, I would just subtract 4x. So we'll end up with y equals -4x minus 2. Then, once we have that, we can graph our two equations. So to do that, let's think back to what we did, or what you should have learned in Algebra 1 for graphing an equation. We can just use the slope-intercept form. So in our first line, we have I guess before we do that, slope-intercept form, as a reminder, is y equals mx plus b. M is your slope, b your y-intercept. So we're going to first look at the b value and put a point on the y-axis at that spot. So in our first equation, that's at 5. So we're going to start at the origin and we're going to go up 1, 2, 3, 4, and put a dot at 5. Then our slope tells us how much we need to move to get to the next point. Now this is a 3, which can be written as 3 over 1. That means we can go up 3, 1, 2, 3, and then right 1 for this next point. And if we can't do that again, we can go back to that first point, and instead of going up, we can go down 3, but then we go left 1. We need at least 3 points to make, or the more points we have, the more accurate we'll be. I say at least 3, and then take a straight edge and connect your dots. Straight edge could be anything from a ruler to the side of a notebook. I'm using a pile of Post-it notes while I'm recording this. So we connect our dots. That didn't work out well. We connect our dots. And then we go and graph the second one. And now I'm going to graph the second one in red. So y-intercept is at -2, so we start at the origin and go down 2. The slope is -4 over 1, so we can go down 1, 2, 3, 4, right 1. We can go down 1, 2, 3, 4, right 1. Once we have at least 3 points, we can then graph connecting our dots, going past, because when we graph a system of equations, wherever the two lines cross, which is right here in this graph, that is the solution to our system. And that point is at the x value -1, y value 2. So our solution is going to be the point -1, 2. Let's look at another example. So we'll call this example 2. It's number 2 in the note packet you have. Our system is x minus 2y equals 8 and x equals -6. And I'm going to actually graph that second line right away, because whenever we have x equals a number, that's going to be a vertical line through that value on the x-axis. So we're going to go to the left 6, and we're just going to make a vertical line through that point. Now for the second equation, or the first one, x minus 2y equals 8, we're going to solve that for y. So with this, I would subtract the x first. So we're going to get -2y equals -x plus 8. And then we can divide by -2. Divide everything by -2. So y is going to equal 1/2 x minus 4. So I'm going to go and put my first dot at 4, -4 even, on my y-axis. And then I can move up 1 and right 2. From that spot. I can even go down 1 and right 2. And then we can connect our dots. And we mark where they cross. That is at the x value, -6, and the y value, -7. So our solution is -6, -7. Let's look at number 3 now in the note packet. So we're going to have the system 3x minus 3y equals -15, and x minus y equals 2. Okay, so we're going to solve for y. So in the top one, I notice everything's divisible by 3, so I'm going to do that right away. I'm going to divide everything by 3. We're going to have x minus y equals -5. So visually we're dividing everything up here by 3. And then I'm going to subtract x, get -y equals -x minus 5, and then I want y to be positive, so I'm going to change the sign of everything. So we're going to have y equals x plus 5. Now let's do all that with the second equation, solving for y. So we've got x minus y equals 2. Let's start by subtracting x. We've got -y equals -x plus 2, because the 2 is positive, and we want y to be positive, so we change the sign of everything. We're going to have y equals x minus 2. So let's graph those equations. First, x plus 5, we go up 1, 2, 3, 4, 5, and we put a dot. We can go up 1, right 1, and we can continue that pattern. We could even have gone down 1, left 1. We connect those dots, and then we can graph our second line. Now here we're going to go first to -2 on the y, and then we're also going to go up 1, right 1. Now these two lines are parallel. If we remember from earlier algebra classes, the slope of the two lines, of these two lines, is the same. If the slope is the same, the lines are parallel. If that is the case, we say that the solution to this is that there is no solution. Remember, the solution to a system of equations is where those lines cross. And if the lines are parallel, they'll never cross, so there can never be a solution to this case. Let's look at one more graphical example. So example 4, we're going to have the system 2x plus 3y equals 9, and we're going to have the system 6y equals 18 minus 4x. Now I'm going to solve for the second equation first, only because there's less work. I have to divide everything by 6 to get y by itself. So I'm going to have y equals -4 over 6 can simplify to -2 over 3. X, 18 divided by 6 is 3. So we've got -2/3 x plus 3, and then we'll solve the other one. We're going to subtract 2x first, so we'll have 3y equals -2x plus 9, and then we can divide everything by 3, so we're going to get y equals -2/3 x plus 3. Well, these two equations are the same. So let's graph them. We only have to graph it once. So we're going to go from our origin up 3, and then we're going to go down to right 3 to find our next spot. We can connect the dots with the straight edge. Now, when the lines are the same, every single point is where they cross. So in this case, we say we have infinite solutions. And that's solving a system of equations graphically. So we talked about Well, actually, let me just summarize what we've talked about. In our first two examples, we noticed that the lines crossed at one point. That meant there was one solution. So if we do graph them and get one point where they cross, one solution. In our third example, we graphed, they didn't cross at all. We were able to graph two lines. Since they don't cross at all, they're parallel, there's no solution. And in this last one we looked at, the equations were the same, which means the lines are the same. If the lines are the same, there's infinite solutions. In our next video, we're going to look at how to solve a system by the substitution method.